All right, our last reliability measure, inter-rater reliability. This is simply, again, how many times do different raters, different people observing some phenomenon or some behavior, do they get it right? How many times do they agree upon what they're observing? And it's simply the number of times that the people agree divided by the number of possible times that they can agree. So in this case, why don't you go ahead and take a moment to see how many possible agreements are there and how many times did they actually agree. Go ahead and pause the video, try to work this out and see if you can come up with your inter-rater reliability coefficient. Alright, so hopefully you worked through this, and essentially each row is number of possible arguments. Did they agree? Well, we count 1, 2, 3, 4, all the way. We have 20 possible agreements. How many times did they agree? Well, we can count all of the ones where we can see that there were 2 times that they disagreed. So 18 times they agreed. So we set this up. 18 divided by 20, 0.900. Our inter-rater reliability, 0.9. You also may see something else set up this way. How many times are there agreements? Each column represents a possible agreement. So 1, 2, 3, 4, 5, 6, 7. How many times are there agreements? Well, we have 2 X's, that's an agreement. X and O, non-agreement. 2 O's, yeah, that's an agreement. 2 X's, third agreement. XO, no. XX, yep. XO, no. Well, so we have 4 out of 7 agreements. Inter-rater reliability, 0.571. This is the simplest reliability coefficient to calculate. So now that we've talked about our 4 different types of reliability, when we have our reliability coefficients, we want them to be 2 things. We want them to be positive and not negative. So you think about the 4 measures: test-retest reliability coefficient, parallel forms reliability coefficient, internal consistency, your Cronbach's alpha coefficient, and your inter-rater reliability coefficients. Which of these 4 can be a negative number? Well, when you think about test-retest reliability, we have Pearson's correlation coefficient, little r. Is it possible that we can have a negative coefficient? We sure can. Remember, correlation coefficients range from -1 to +1. What about parallel forms reliability coefficients? How do we determine that? Just like test-retest, Pearson's correlation coefficient. And can those be negative? They sure can, range from -1 to +1. So when we have parallel form reliabilities and test-retest reliabilities, they can be positive or negative, but we want them to be positive. Internal consistency, our Cronbach's alpha coefficient, it can never be negative. And our inter-rater reliability, think about the calculation we just did. Is it ever possible that we can have a negative number? No. So, test-retest, parallel forms, we have to worry about negative numbers. Cronbach's alpha, which is internal consistency, and inter-rater reliability, we don't have to worry about negative numbers. But regardless, we want our reliability coefficients to be positive and not negative. When we do have a positive reliability coefficient, we want that coefficient to be as large as possible, between 0 and positive 1. And so here are the thresholds. Make sure you know these thresholds. Cronbach's alpha, our internal consistency reliability coefficient. If we have our Cronbach's alpha greater than 0.70, we have good internal consistency. We have reliability among all the items within a scale to measure that scale consistently. The higher the Cronbach's alpha, even more reliable, even more internal consistency. When we have parallel forms and test-retests, again, this is Pearson's correlation, little r. We want it to be greater than 0.8. So if you think about how we interpret little r in terms of strength, 0.8 or greater indicates very strong relationship. So if we have a very strong direct relationship, then we can say that we have parallel reliability, test-retest reliability. Has to be greater than 0.8. And then our inter-rater reliability. As long as we get half of the agreements correct, we can say that we have inter-rater reliability among all of our raters. So make sure you know the thresholds, because these are the numbers that will allow you to either say whether or not a measurement tool is reliable or not. How do we establish reliability? What if we don't meet those thresholds? What can we do? Well, one of the things we can do is standardize instructions. With the 8-foot up and go, I have about 10 research assistants that I've trained this semester to administer the 8-foot up and go. I want to make sure that all 10 of those research assistants say the same thing and administer the 8-foot up and go the exact same way. If one research assistant deviates from how to administer the test, the results from whatever participants they administer it to, those results are going to be inconclusive. They're not going to be real data that we can collect and use, because all the other research assistants administered the test one way. If this one rogue research assistant decides to completely say it differently and give the wrong instructions or give it differently, well, that's going to skew and screw up your data. So we want to make sure that you standardize your instructions so that you can establish really, really good reliability. We can also increase the number of items, or we can delete unclear items. And this is talking a little bit about internal consistency, right? We can add some more items in there, or we can take some out. We're going to reduce and make up more room for our real estate, questionnaire real estate. Reduce the burden on participants. But sometimes we need to put more measures in there, more items in there, so that we can get a better reliability. Make sure that all the items are really measuring what it is that we wanted to measure consistently every single time. When you're thinking about parallel forms, making the tests not too easy or not too hard. Again, it wouldn't be fair that if you got test A that was a super, super hard one, and then your neighbor got test B, which is a super, super easy one, well, that's not going to really measure who knows what, how well you guys know the content, and then compare your scores to each other. It's not going to have equivalence. You're not going to have parallel form reliability. So making sure that they're even keel, that they're the same. And then thinking about true score and observed score. If you can reduce the effects of external distractions, test anxiety, temperature being too cold in the room, getting sick, all these different things, then what you actually observe, your score, is going to be almost, hopefully, as closely reflective of what your true score is. We want to reduce as much error as possible. So just to summarize, I think this is a really nice visual that a lot of my past students have really appreciated in terms of understanding these four just a little bit better. So inter-rater reliability, again, the number of agreements over the number of possible agreements. We're having two or more different people observing the same thing. Do those observations of the two people equal? Test-retest reliability. We have the same individual. Have them take the test at one time point, have them take a test at a second time point. Do those tests correlate well? Are they the same? Do they jive up? Parallel forms reliability. We have the same individual. Have the same individual take the test A. Have them take test B. Do those two forms jive up? Do they have the same score? Hopefully they do. Internal consistency reliability. One individual checking to see, do all these different test items, item number 1, item number 2, all measure the same thing? Get rid of any ones that don't, that increase your reliability.